Hello and welcome to the division applications video. This is going to be similar to our last applications video, except instead of using factoring and the quadratic formula, we are either going to be using synthetic division or long division. I'm only going to be doing one problem with you. You can find the notes above in the description on the Canvas page. I don't have a separate sheet for this. Let's take a look at problem number 3. The volume of a rectangle solid is given by the polynomial 3x to the fourth minus 3x cubed minus 33x squared plus 54x. The length of the solid is 3x and the width is x minus 2. Find the height of the solid. So another way this is different than our other application video is I'm not solving for x. I don't need to find x. I'm just trying to find the expression. So this expression of 3x is okay. The expression of x minus 2 is okay. Now I want to find the height. So just a reminder, kind of like length times width is going to give us area. In this case, length times width times height is going to give us that volume. So I'm going to fill in everything that we know. So we know that our length is 3x times our width of x minus 2 times our height, we don't know that yet, so I'm going to leave that as h, is equal to the polynomial that is the volume. So we're going to go through and figure out what we can find. Well, if we divide both sides by 3x, what I'm doing here is I'm taking a 3 out of each of these as well as an x. So this is going to end up being x minus 2 times h is equal to x to the power of 3, because we have 3 divided by 3, and x to the fourth divided by x, minus x squared, because 3 divided by 3, x cubed divided by x, minus 11x, because negative 33 divided by 3 is negative 11, x squared divided by x gives us x. And lastly, as our constant, we'll have a plus 18 because we have 54x divided by 3x, leaving us with that 18. So from here, in order to get h by itself, I'm going to divide both sides by that factor of x minus 2, leaving me with h is equal to, x cubed minus x squared minus 11x plus 18 divided by x minus 2. And now this looks just like the problems we did the other day. But before we do that, I do want to do my best to draw what this is going to look like. So if I was to draw myself a box, because we want to see some diagrams, again, we know that this width is x minus 2. This length is 3x. Oh, this is going to be a little messy. That's why we erase things. Whee! Okay. And what we're looking for is this height right here. So I'll fill that in when I can find it. So let's see. So you can use synthetic division or long division here. I'm going to use synthetic division just because it's a little bit quicker. So remember, when we use what root to use, we're going to put it in the box right here. Oops, sorry, that is still in highlighter. There we go. So since this is an x minus 2, we're going to put a positive 2 inside here. And then we're going to be using all of our coefficients of this term. So that's going to be 1, a negative 1, negative 11, and a positive 18. So our first step is we're going to bring down whatever number is out in front. We are going to multiply this number to what we have in our box, so 1 times 2, and we're going to write that right here. That's 2. And then we are going to add these two terms together, so negative 1 plus 2 gives us 1. And I'm going to continue that circle again, so 1 times 2, we'll put that right here, of 2. We'll combine these two numbers, remember we're adding them, so negative 11 plus 2 gives us a negative 9. Do our circle, negative 9 times 2. What goes right here? This is negative 18. Negative 18, 18 plus a negative 18 is going to give us 0. And I go, oh, hey, look, that is my remainder. So I know that this worked out well. So when we look at the numbers we have left, what do they mean? Well, these are the remaining coefficients. Since we divided out an x minus 2, we got to take a term off of all those x's there. So our highest value now is going to be x squared plus x minus 9, which is going to be our brand new length. So if we go back over to, height, brand new height. So if we go back over to our diagram, we can write that in as x squared plus x minus 9. And if I was to write the sentence, I might say the height of the rectangular solid is x squared plus x minus 9. That's all we need. You do not need to continue on farther. We have no units, so this is it. This is what one problem looks like. Let me know if you have any questions, and I look forward to seeing you next class period.